Can we develop a sensor system targeting the user with perhaps less number of sensors? So to talk about these, we have Mr. Sanjaya Mallikarachchi. He's a young biomedical researcher and a mechanical engineer who was engaged in multiple projects with the Center for Biomedical Innovations. His major involvements included developing 3D printed spinal orthosis for scoliosis patients and developing a cost-effective motion capturing system in collaboration with Kyra Sensing, which he'll be presenting today. He obtained his bachelor's degree in mechanical engineering from the University of Maratua and has engaged in diverse array of research, technology development projects in robotics, mechatronics, command control systems, among others. So today he's going to be talking about gait analysis hardware and software. Over to you, Mr. Mallikarachchi.
Okay, I hope everyone can hear me and I'm audible enough for you all. Thank you very much, Dr. Noeline, for the great introduction, and it's a pleasure to be a part of this workshop. So let me share my screen. Okay, so I hope everyone can see my screen. Okay, so I'm Sanjaya Mallikarachchi, a research engineer representing Kyra Sensing. And in this session, I'll be discussing about the system, an affordable system that we have been developing throughout the past 6 to 10 months, and specifically for gait analysis. So in case if you're wondering what is the system that we are developing, actually it's a motion capturing tool with IMU sensors. So I'll start with a quick video so that you can understand what will be our system. So I hope you get the idea that we are trying to capture the motion using IMU sensors. And Worksense is the product that we are trying to develop. It's an IMU-based motion capturing system specifically for gait analysis. And it is actually the requirement came from the clinicians that they wanted a affordable system, as Ms. Sinthuja explained in the previous session. So we kind of get together and discuss whether we can develop a system in Sri Lanka using IMU sensors and provide an affordable system. So IMU stands for Initial Measurement Units. So I think Dr. Tirosh explained about it at the keynote speech. And it consists with the gyroscope, the gyrometer, and the accelerometer and the magnetometer. So there is a sensor fusion happening inside, and then it provides us the orientation. So you can find the same sensor in your smartphone, and it provides us the orientation after filtering at accurate position. So we are using that orientation to develop a system for motion capturing. And why IMU sensors? I think you understood that most of the vision-based systems are really expensive, and also like it has some limitations. For an example, you need a specific lab in order to capture the motion using cameras, but when it comes to IMUs, you don't need a specific lab. Also, if you have any experience in using vision-based system, you need to calibrate the set of cameras. So it is actually a time-consuming process, but with the IMUs, it is not in our system. It's just 2-3 minute work to calibrate all the sensors in our system. So we originally developed this system for gait analysis, but later on we realized that since we are capturing the motion, we can use it for the other applications as well, such as sports. And if I discuss about the hardware system, you can see the sensor, full sensor system here. You can see the full sensor system here. In the briefcase, it has actually 15 sensors. And we have 3 dongles, which the sensors will connect via the dongles wirelessly. So they are not, in dimension-wise, they are not so big, so easy to handle, and the weight is very minimum. So these sensors are not manufactured in Sri Lanka. It's a product in US. The name of these sensors are Yost. Dr. Oren also discussed about these sensors. So at this stage in the beta version, we are not targeting to develop a sensor here. What we are trying to do is develop the software, because it's the part that in most of the cases, the cost is really high. So at this stage, we are trying to reduce the cost of the software too. So also with these sensors, you can see the dimensions, and after wearing it, so it can be practically used even for a small child. So one major advantage in the IMU sensors is that the higher sampling rate, even after filtering, you can go up to 200 hertz. So it's ideal for a fast moving application like for an example athletics or any other sport which the movements are really fast. And it provides us the raw data in the form of coordinates and rotation matrices, etc. So we can develop our own software system using these raw data. So if I talk about the software development, so we realize that we need to minimize the cost of the software. So we make sure to use open source development tools. So the system is, the software is entirely developed using Java, and then we use JMonkey engine for the visualization of the avatar, and MERCon to build the avatars that we want. For an example, you can see in the coming slides, we can customize the avatar sizes. If it is a small child, we can select the smaller avatars depending on the age. And to maintain the data, we have an embedded database. For that, we use SQLite. And for the report generation, for the clinicians, they need an instant report. So with Jaspersoft, we create them an instant report for the motion. So continuing with that, so this video shows you how to set up the system. So you have the dongle hub here, and you need to connect the dongle to the dongle hub, and then the hub into the tablet. And here's the sensor, and then you need to put it inside to the strap. And then these sensors are wirelessly connected to these dongles. So it's quite easy to use, just plug and play kind of thing. So it will save a lot of time. So you can see how it looks at the end after wearing the limb. And you can see some testings we have done, the system we are developing. Okay, so if I go through the software, it has a few features which is very handy for the clinicians that they can use it very effectively. So if I go through the main window, you can see you can connect all sensors here, 15 sensors, and you have the offline mode and the real-time mode here. So you can switch between offline mode and the real-time mode. And in the real-time mode, you can make sure that once all the sensors are connected, you can see the avatar is moving. If not, and also you can see in the status here, it will display that it is not connected. So you can easily figure out which sensor is not connected and which is connected. And if you have recorded a session and if you want to replay the session, you can switch to offline and pick a session that you have previously recorded and then play it. Also generate reports out of it. And as I mentioned earlier, you can select customized avatars because it makes sense, because it can be a small child that you are analyzing the gait cycle. So depending on the ages, we provide the feature to select an avatar. Also, we are planning to introduce a kind of a sensor holder thing for small kids. We feel like the current straps are quite big for them. Can play with that. The data logging tab, you can log the data in this tab, because what you have to do is once you have connected all the sensors, you just give a name to your session and then you start saving the data. So all the orientations in opinion format will be saved inside the database that comes with the software. And the most important thing, the report generation, you can see the clinician can first save the data inside the database and then select the angle that they want to observe, so that they can customize the plots that they want to see in the report. So we generate it in a PDF format. Later on, they can print it or maybe give it to the patient. So over time, they can observe the effectiveness of the treatment process. And the sensor arrangement of the system is like this. So you can see the motions here that you can capture. So you can select which motion, what is the motion you want. Let's say for the knee, if you want to see the flexion and extension, you can select the motion that you want to see in your graph, and then you can generate the plots. So what we are actually doing inside the software, so we are looking at the angle of this joint. So we are calculating the angle between these two sensors. And likewise, any joint angle in 3D way, in 3D format, we can generate. So like the elbow, we take these two sensors and then inside our algorithms, we calculate the angle. And I mentioned about the offline reading, so it is also really important. Once you recorded the data, you need to, if you need to visualize in the format of avatar or the So as a plot, you can again play these buttons here, and then also pausing them, and you can observe what's happening within the data collected. So here is a video with the full sensor system. Still we are in development process, so you can see a small lag with the system. So we are still trying to improve that problem, but it works fine as you can see. But one problem that we have faced, like it is perfectly fine with 2-3 sensors, but when it comes to 15 sensors, we kind of losing the sample rate. So in these days, we are actually trying to improve the problem. So you may not need to use all the sensors for your requirement. Let's say if it is only a lower body analysis, you may need 7 sensors. So likewise, you can customize. And the clinical relevance, so I mentioned that we started with the requirement of on the clinical side. So we focused on the gait analysis. So it's a very good tool for a diagnosis, and also to evaluate the treatment, and physios can see whether the patient is improving looking at the graphs. And in the area of rehabilitation, so there are limb amputees, both upper and lower. So in order to improve their gait cycles, or maybe their other activities of daily living, they can use this tool and see whether they are ready to work better in their day-to-day work. Also for the patients recovering after accidents and injuries, so wide range of applications here in the area of clinical area. So this is a video for a cerebral palsy kid that you can see. Even for a small kid, we still can use this sensor system. And you still need the physio. We are not going to replace the physio. It's just a tool to improve the experience, improve the improve the way of measuring things. So it will still be under the guidance of the physio, and later on the physio can interpret the data collected. So the clinical applications, and it can't limit the cycle. So still the sensors are not capable of using in underwater environment. Maybe in future we can introduce some water resistant sensors so that we can analyze the gait cycles in the water. And the other major area that we saw, this tool can be used as a research tool, because we are planning to develop some plugins. Using these plugins, we can export the data, export the kinematic data, and then provide them into the software tools like OpenSim and anybody, because they have their models, musculoskeletal models, so that we can analyze the forces on upper and lower bodies. So it will be very useful for the researchers, and it's affordable. All you have to do is just export the data and feed it to the OpenSim or anybody if you have the license. And again, another great tool from Germany called Ergonomics to analyze the workspace conditions, to analyze the posture of the workers when the work schedules are planning. The supervisors, managers can look at what is the motion that their workers are going on. Looking at that, they can decide design and then plan the working schedules. And another future improvement that we are targeting, like integration of the pressure mats and the force plates, so that we can simultaneously measure the ground reaction forces. And currently we are trying to obtain it using IMU sensors, but we feel like it's not the best way to get it. So we are planning to integrate the pressure mats and the force plates too. So the story of our company, we are not a very big company, we are a small startup. So it wasn't so easy, but myself and the undergraduates work, also the graduate works, managed to develop the system up to this level. So let's hear about the story a bit.
Worksense by Kairos Sensing. All began with a cause to meet a need in rehabilitation care. It was evident that children in Sri Lanka who are diagnosed with cerebral palsy, postural deformity, don't have access to the technologies that would aid their quantitative assessment and rehabilitation. Sri Lanka didn't have a commercially available 3D motion capturing system to analyze gait and movements, which is so essential to improve treatment outcomes in such developmental disorders. And so, with the intention of serving this unmet need, Kairos began its mission to develop Worksense. In October 2020, a team of 2 research engineers and 3 engineering interns who were keen to learn and contribute stepped up to the task. They began developing the conceptualization and the architecture of the software and the hardware systems for a whole body gait analysis system. The initial funding came from Kairos Sensing. The team had a key breakthrough when they were able to secure 2 other clients for funding: the National Center for Children with Cerebral Palsy and Other Developmental Disorders by MJF and the Center for Handicapped Sri Lanka came on board as beta partners to further develop the product. The financial stability provided by their partnerships helped to overcome the challenge of a lack of funding, which allowed the project to go ahead. Yet, as the third wave of the pandemic prolonged, it did threaten to jeopardize the project. First, with a long delay in shipping and clearing of some of the hardware from the US, and then the team was unable to meet for a long time due to social distancing requirements, and eventually the internship itself came to an end, reducing the team to just 1 person. So an entirely new team had to be recruited and trained to carry out the work in a very, very short period of time. Yet no void was left, as an eager group of undergraduate students and a young graduate stepped up to the mark. to see the project through. The learning curve was steep, yet their commitment to making a worthy contribution helped them move the project forward, ably supported by the other interns from past as well as others who came around to help and support them. I have to say, this really shows what young students in Sri Lanka are capable of. This goes to show that we don't lack the skill. We have it. It's just that an opportunity needs to be given to such students, which is what I believe Kairos was able to do for them. I'm really happy to say that we've been able to develop a team culture that isn't just about work alone. It's also engaging and fun-filled. There's plenty of learning, mentoring, knowledge sharing, and camaraderie despite the lockdown. It was also an opportunity for students to gain some early experience, even while still studying, which really will help build them up professionally. Ultimately, the product that these young group of engineers, engineering researchers help to develop is a product that people across clinical, biomechanical, rehabilitation, and hospital settings will use, and also universities will use, extending it as a research tool. It really is a product that we foresee Sri Lanka embracing and using widely to help people from all walks of life.
Okay, so with that, we have come to the end of this session, and you can read about us more in through our website www.kairosensing.com.